We've looked at solving triangles in Chapter 6, Section 7, where we were solving right triangles. This lesson and the next lesson we'll look at solving non-right triangles. When we're looking at non-right triangles, one of the options we have is the law of sines. This is your law of sines formula up here at the top, where capital A represents the angle A, capital B is angle B, capital C is angle C, where lowercase a is the side opposite angle A, lowercase b is the side opposite angle B, C is the side opposite angle C. Whether you're using the first one or it's reciprocal, the second one doesn't really make a difference. Now you want to use law of sines when you know an opposite pair, meaning when you know an angle and the side opposite. If you know an angle and its opposite side, that's an opposite pair and you can use law of sines. Now, if you are given a side-side angle, an angle-side angle, a side-angle side, or three sides, you know you only have one triangle because those are different ways to prove triangles congruent from geometry. Now, if you're given all three sides, or angles, I mean, you need to be aware that the angles have to add up to 180. Also keep in mind that if you have all three angles, that does not actually prove any triangles being the same, and there's infinitely many triangles available with that. Also keep in mind when you know all three sides, that the sum of the two smaller sides has to be more than the third side. Now, when you're dealing with a side-side angle, and we always go side-side angle, never the other way around, sometimes it is no triangles formed, sometimes it is one triangle formed, like the ones up here are, but sometimes it's two triangles. Well, let's go ahead and use our law of sines to help us out here. First thing you want to do is you want to go ahead and draw yourself a triangle in the context of your problem. We have an obtuse angle, so I'm going to draw a triangle that's obtuse. We also know that we have this angle here, we have this side here, or angle, and then we have this side here. Well, we have two angles in a side. Two angles in a side means it's either going to be this one here, or it's going to be the first one. However, we know it's the first one because is your side of 10 in between your two angles? The answer is no. So your side here is not between your two angles. Well, we do have our opposite pair. Our opposite pair is over here in our triangle. It's our angle A and our side A. So from that we can go ahead and figure out our missing information. Well, since we know angle B, the next thing I would want to find would be side B. So we'll use law of sines. We'll go the sine of our angle over the side opposite that. So sine of 123 over 10. Sine of 16. Well, I was going to have you find side B first, but we're only looking for what it says of C. Now, where does the 16 come from? Well, the 16 comes from, well, all three of these angles have to add up to what? All the angles have to add up to 180. So this angle up here of angle C is 180 degrees minus your 123 minus your 41, and that's where the angle of 16 degrees comes from. Since we're only asked to find C, I'm going to go and set this up like I had before, the sine of my angle C over side C. Then let's go ahead and cross multiply, taking the C times this top and the 10 times this other top. Now we want to finish getting C by itself, so you got to get rid of the sine of 123, so you need to do some division. Then you go ahead and type it into your calculator, and you get approximately 3.29. Well, Here we have another situation. You have two angles and you know it's 115 yards in between. So you draw a triangle in the context of your problem. You realize that yes, we have two angles that we know, so we can automatically figure out the third angle, because when you know two angles, you can get the third one because they always add up to 180. This is the side that we know in between our two given initial angles. So in this situation, we have two angles again, and we have a side, and in this case, it's a side in between your two angles, so we know it's an angle side angle, which once again is only one triangle. So we don't have to be concerned about multiple triangles. That's only in your side angle. Well, we're going to go ahead then and find our missing information. You might say we were not given an opposite pair, but we did have an opposite pair. Our opposite pairs are angle that we figured out up here and our 115 on the bottom. So we'll go ahead and go the sine of our angle of 17 over the side opposite of 115. And in this case, I'm going to go ahead and find A first. So I need to go the sine of my angle A over the side of A. Once again, cross multiply. Go ahead and get A by itself by getting rid of the sine of 17. Calculator ready form. Now type it into your calculator, and you get approximately this answer. Well, we can repeat the process to be able to figure out side C. But instead of using the A stuff over here, we'd have to use the B stuff. So I'm going to still have the left side be the same. Then I'll go the sine of B, or C, over my C. Once again, I want to cross multiply. Get C by itself by dividing by sine of 17. Calculator ready form, type it in, and you get your decimal approximation. Well, when we're dealing with our side angle situation, you're given this side right here. You're given this side over here. And you're given your angle over here. Now, this angle and the blue side are fixed. We don't know those. In each problem, when you're dealing with a side angle, this side over here would be fixed. Well, it's possible if this side here was too short, it would swing down, and if I can get a hold of it here, and it would be too short to form a triangle. So there'd be no triangles formed. Well, if we tried a slightly different situation and made this a little bit longer and then swung it down, it'd be long enough just to form one triangle, and in this case it's a right triangle. Well, if we go back here and make it a little bit longer to explore a third situation, it could come down and touch here, forming one triangle this way. Or when we swing it over here, we get a second triangle. We can swing it because this angle at the top here is not fixed. We don't know that angle. So in that situation, you could have one triangle formed here, or swinging it back over here, get your second triangle. So that's how you can sometimes get two triangles. Now, it is possible that this side right here is really, really long. It's only one triangle, because if I tried to swing it over here, it's one just big triangle, because if I swing it, it's going to be too big to form a triangle over here. Now, that's when we're always dealing with an acute angle, an angle less than 90. When you're dealing with an obtuse situation, the only way for this right here to form a triangle is if this opposite side is longer than your adjacent side. So the obtuse situation is easy. The only way to get a triangle is if the opposite is greater than the adjacent. If it's not greater than the adjacent, it's too short to reach down to form a triangle, then there's no triangles formed. These statements here basically summarize what we have for finding the number of triangles.